this is the key to your review for trig test number 2. And just to clarify, because it doesn't really say this on here, the test will be half non-calculator and half calculator. So basically the front of this review is what you're expected to be able to do without a calculator, and then the back you would have it with a calculator. So just know that. I know some of y'all were helping or using the calculator to help you with the square roots and stuff. I mean, that it is what it is, but just know that you're not going to have one on the test to do that. All right, so number 1. 2, negative 11 is a point on the terminal side of theta. In standard form, find the exact values of the trigonometric functions of theta. Oh my, how many questions I had on what the terminal side is. Well, think about what terminal means. What does it mean to terminate, to end, or to stop? So here is my coordinate plane, and then I need to plot my point, but just kind of ballpark it. So I go to 2, negative 11. Doesn't even really mean if necessarily if it's to scale. There's my point, and then I connect that. Okay, so theta. Think of the theta. This is all ties to everything that we've done. We measure theta here at the origin, right, and how it rotates around. So your angle is in here. This is the radius that you connect to get your point, and then you always make the triangle perpendicular to the x-axis. I saw some crazy wrong ways some of y'all were drawing your triangles. I do not know where you got that information from. And then I had questions on, I'm so confused about which one the angle is. The angle is at the origin. All of these degrees and radians and stuff we've been measuring, it's all right here, and it's created by that radius that is rotating around. So this is the angle. Right, so then I'm going to label it, this is 2, and this is negative 11. So I need to find the radius, which means I do Pythagorean theorem. So 2 squared plus negative 11 squared equals r squared. This is 4 plus 121 equals r squared. R squared equals 125, which means r equals the square root of 125, which is 5 square root of 5. And the radius is never negative, so you don't even have to question that. All right, so then I'm going to write out my little list here. So I know that x is 2, y is negative 11, and r is 5 square root of 5. Okay. So the other thing is that I got a lot of questions on is, how am I supposed to remember that it's x over r and y over r and those sorts of things? Well, you already know that when we use the unit circle, sine is y and cosine is x. That's still the case, but the reason they're just x and y is because the radius is 1. So now the radius isn't 1. So sine is still y, but it's y over r. Cosine is x over r. It's also still and always will be opposite over hypotenuse and adjacent over hypotenuse. SOHCAHTOA. So it's the same thing. So when I look at sine and I know that sine is y over r, I can put negative 11 over 5 square root of 5, which is the same thing as looking at this, and it's opposite over hypotenuse. It's the exact same thing. All right, so then I can't have a square root in the denominator, so I rationalize, and when I rationalize, I get negative 11 square root of 5 over 25. That is my answer. The cosecant is a reciprocal of sine, so I could take the reciprocal of that one, but then I'm going to have to rationalize, so why would I want to do that? I could take the reciprocal of this one, so it's negative 5 square root of 5 over 11, makes my life a lot easier. Cosine, x over r, 2 over 5 square root of 5. Watch your signs here, right? And so here again, adjacent over hypotenuse is the same thing. Then I rationalize. So I get 2 square root of 5 over 25. Secant is a reciprocal of cosine, so this is 5 square root of 5 over 2. Tangent is y over x, negative 11 over 2. It's also opposite over adjacent, just like it's always been. And then this is negative 2 over 11. Okay? And there you go. And double check yourself. You are in the fourth quadrant. And in the fourth quadrant, the only thing that is positive is cosine and its reciprocal. These should be negative because we're in the fourth quadrant. All right, so let's look at number 2. Number 2 is a very similar question, except it doesn't give you an ordered pair, so you have to decide what quadrant you're in. So we look at this. I'm going to draw a little tiny coordinate plane here. So cosine theta is negative. Well, I know cosine is positive in 1 and 4, which means it's negative in 2 and 3. then sine is less than 0, so sine is negative. Well, I know that sine is positive in 1 and 2, so it has to be negative in 3 and 4. And then this is where they overlap, so my triangle is in quadrant 3. So the first thing you should do, because some of y'all were like stuck and confused before you did anything, draw a triangle. So I'm going to draw my coordinate plane again, then I'm going to draw a triangle in the third quadrant. And here's what you don't do. So don't do this. I've seen, oh gosh, I saw triangles that were drawn like this. That's a big fat no. Because remember, your angle is here. I have not drawn a single triangle like that. And then I also saw people drawing triangles like this. I don't even know, some crazy stuff. Or maybe you drew it like this, but like went over here. I don't know what's happening. So I'm in the third quadrant. I have a radius. You do not make it perpendicular to the y-axis. I hadn't done one single triangle like that. It is perpendicular to the x-axis. There is my triangle. This is my angle. Okay? So then I have cosine theta is negative 6 over 7. Cosine is adjacent over hypotenuse, or x over r. So that makes this 6 and this 7. And then depending on the quadrant you're in, that's how you decide what's negative. In this case, it's pretty obvious, but like if it was a tangent, then one of them would be negative and one of them wouldn't. So but the negative 6 over 7, to get a negative, only one of these two can be negative. It's not going to be the radius, so it's this. Plus, I'm in the third quadrant, so my x is negative. Then I need to do Pythagorean theorem. So I'm looking for y. So I have y squared plus negative 6 squared equals 7 squared. Right? So y squared plus 36 equals 49. And then y squared equals 13. So y is equal to the square root of 13. Technically, it is plus or minus the square root of 13, and that's important because, again, I am in the third quadrant, so this is a negative square root of 13. That's why it's important that you not only draw and label the triangle, but you put it in the correct quadrant so you can know in quadrant 3, every single point you end up with has a negative x and a negative y. So now I have all of my pieces. I have that x is negative 6, y is negative square root of 13, and r is 7. So I'm going to go fill this in. Sine is y over r, so it's negative square root of 13 over 7. Cosecant is the reciprocal of that, so it's negative 7 over the square root of 13, which is negative 7 square root of 13 over 13. Cosine is x over r, so it's negative 6 over 7, and secant will be negative 7 over 6. Tangent is y over x, so that's negative square root of 13 over negative 6, so it's just square root of 13, excuse me, over 6, because it's negative over negative. Cotangent is the reciprocal, so it'll be 6 over the square root of 13, so that's 6 square root of 13 over 13. Once again, I am in quadrant 3. In quadrant 3, the only things that are positive are tangent and its reciprocal. These two answers are positive, the rest of these are negative, and it all jives. There we go. All right, let's look at our exact trig functions. So I have sine of a negative 4 pi thirds. Okay, so using my hand trick, I know that the sine of a pi thirds angle is square root of 3 over 2. Then I have to decide if it's positive or negative. Negative 4 pi thirds goes this way, and I end up in the second quadrant. In the second quadrant, sine is positive, therefore this is my answer. Secant is the reciprocal of cosine. Cosine of a pi sixths angle is the square root of 3 over 2. Okay? And so this is the reciprocal, so the reciprocal of the square root of 3 over 2 is 2 square root of 3 over 3. And then I have to decide if it's positive or negative. So negative 7 pi 6 also puts me in the second quadrant, and cosine is negative in the second quadrant. That is my answer. Cosine, 7 pi fourths. Cosine of a pi fourths angle is square root of 2 over 2. Then I have to decide if it's positive or negative. So 7 pi fourths, that's in the fourth quadrant. That's where cosine is positive. That's my answer. Cotangent is a reciprocal of tangent. So tangent of a pi 6 has 2 3's in it. It's the square root of 3 over 3. And then the reciprocal of that is the square root of 3. That's in quadrant 1. That's my answer. Okay, that concludes the non-calculator portion. So let's flip it over, look at the calculator portion. Okay, so I need to find the area of the triangle below. So my area formula is 1/2 A times B times the sine of C. And I have to have a side angle side situation to make that happen. I do not have side angle side, I have angle angle side. So I need to find another side. So I'm going to find, let's see, I have 49 goes with 15, 39 will go with this, I'll call it X. Okay, if some of y'all found this side as you're working it, which is absolutely fine. So your work will look a little bit different as we go through, but in the end we should have the exact same answer. So I'm going to have the sine of 49 over 15 equals the sine of 39 over X. Okay, so I cross multiply, do my thing, and I get X equals 12.5 something, and I store it in my calculator. Right? So now that I have that, I have these two side lengths. Since I have these two side lengths, I have to use this angle in my work. Okay, so then I need to add these together, subtract from 180, and I get that this is 92 degrees. So then I'm going to get that the area is equal to 1/2 times one side, which is 15, times the X that's stored in my calculator, times the sine of the angle that's included, and that's 92. So when all is said and done, I get that the area is equal to 93.752 millimeters squared. 3 decimal places unless you are told otherwise. Okay, so another area, this time I'm using Heron's formula because I have 3 sides, so I have to find the semi-perimeter first. It's going to be half the perimeter, so half of 8 plus 13 plus 15, which is going to give me 18. Then I substitute it in the formula, which looks terrible, but it's pretty easy to remember. It's the semi-perimeter times that minus a side, and then do that for all the sides. Then it's 18 minus 13, then it's 18 minus 15, and I can type all that in at once in my calculator. In this case, this one, just by the nature of the number, you get a square root answer. Most of the time you'll get decimals. If you get a square root answer like you do here, I'll take either one. The calculator first tells you 30 square root of 3, and that's fine. That's inches squared, right? But if you get the decimal, it is 51.962 inches squared. So that just tells you that one of the angles that you have in there is it's a triangle that has some special angles in it. So, but either one of those is fine. You wouldn't have to have them both. Okay, so number 9. There's a little side note about number 9. I realized today in discussions with some people that were getting different answers than me that I did not teach you wrong, but I failed to stress a certain point, or probably even ever say it, because the way that I solve these, just by the nature of it, it always just takes care of itself, and I didn't really point that out. So let me kind of go through and tell you what happened here. So when I did this the first time, I went through and I found angle L first, just because that's the one I picked. Okay, so I found angle L, and I got me an answer over here. And then I went through and I found angle K, and I got me an answer here. And then I add these together, subtract from 180, and I got me an angle J. Okay, and that's where my answers came from, and they are actually the correct answers. Then I had a set of people find J first. Okay, so they found angle J. Boom. Okay, using the law of cosines, which was fine. And they got the exact same angle J that I did. But then the next angle they found was angle L using the law of sines, and they got a different angle than me, which means in turn when they add those together and subtract from 180, angle K was different as well. So the reason that happened is because of the whole ambiguous case thing. And I think when we were doing this and we did the law of cosines and we switched the law of sines and I said, as long as you've done the law of cosines, you're good, and then you can move on to law of sines. I left out a hugely important little detail there, is that you have to have found the largest angle before you can switch to the law of sines, because of the whole ambiguous case thing. And that's what was happening today. Because they found J, and then they did law of sines to find L, they hadn't found the largest angle yet. Because I know that, I always find the biggest angle first, and when I was explaining this stuff to y'all, I just kind of didn't point that out. I don't know why. So how do you know which one's the biggest angle? Well, it's across from the biggest side. So this is the side this is the angle we're gonna find, and this is the side. So I'm telling you this, once we go through this, I will tell you what the other options are that you could get, just so that you know if you got if you got different answers, it doesn't mean that you just absolutely don't know what you're doing. It might be because I didn't really make it very clear. So we have to do the law of cosines first. It's the only thing we can do. But I'm going to start with angle L because it's the biggest one. If you always start with the biggest one, then it just takes care of itself, and you can switch to the law of sines. So this is going to be 24 squared equals, then I square the other two sides and add them together. Cosine of angle L. So when I type all that in, and if you need to write other stuff down, whatever, but I get that the measure of angle L is 91.737. And you want to store that in your calculator. So 91.737 degrees. Okay. Now, because I have found the biggest angle, I can switch to the law of sines. Now, it could be that you didn't find the largest angle and you switched to the law of sines anyway, and you still got the same answers I did. So it just so happens that on this one, if you find the two smaller angles first and leave this one to last, then you're okay. So it's just one of those things where, like, sometimes it works right and sometimes it doesn't. So I don't want you to think because you didn't find the biggest one and it worked for you that it's always going to be okay. So I found the biggest angle. Now I can switch to the law of sines because I need another angle. So the next one I'm going to find is angle K. So I'm going to have the sine of angle L, which is stored in my calculator, over 24 equals the sine of angle K over 11. So I cross multiply. When I get an answer, because since I want K, I have to take the sine inverse. And when I do all of that, I get 27.266 degrees. Then when I add those together and subtract from 180, I get 60.997 degrees. Now, I told you I was going to tell you what the other answers were, and I just realized I don't know what I did with the paper that I wrote them down on. But if you angle L, the other answer is 88 something, but that is the wrong answer. This is one of those cases where that does not work. But again, if you find the largest one by the law of cosines, then you're safe to move on to law of sines. Okay? All right, so let's look at number 10. I'm going to find the length of AC. So I'm going to call it x. I have side angle sides, so in order to do that, that's the law of cosines. So that's x squared equals 8 squared plus 9 squared minus 2 times 8 times 9 times the cosine of 76. So I can type all that in at once, but if you do that, make sure you have it under the square root sign, or type it in and then take the square root, or whatever. But I get that x is equal to 10.496 inches, and nobody asked me for x, so that is the length of AC. Okay. Alrighty, so number 11, I have triangle DEF. So angle E is 47, DE is 17, EF is 16, and I'm looking for the measure of angle F. Right? So what I need to do, I have a side angle side situation. My only option here is the law of cosines. So I need to find the other side. That's all I can do right here. I'm going to call this x. So I'm going to get x squared equals 16 squared plus 17 squared minus 2 times 16 times 17 times the cosine of 47. So when I do all of that, I get that x is equal to 13 something, and I store that in my calculator. Okay? So then now that I have that, I'm looking for the measure of angle F. And I would like to switch over to the law of sines here, but I shouldn't. Because have I found the largest angle? And the answer to that is no, I have not found the largest angle. F is the largest angle because it's across from 17. So in order to be safe that I actually get the angle that I want, I shouldn't switch to the law of sines yet because I don't have the largest angle. So I should do the law of cosines again. And I'm looking for this angle here. So the side across from that's on the outside. So this gives me 17 squared equals, I have an x stored in my calculator. So this is x squared, my calculator x squared, plus 16 squared minus 2 times x times 16 times the cosine of f. And then you do whatever you do to get to that point, whether you do it all in one step or in pieces, but you're using that stored x to get that. And then you got to take the cosine inverse, and in the end, you get that the measure of angle F equals 70.487 degrees. And you actually get that if you do the law of sines also. But remember, that wouldn't have worked on the one above it, so, you know, it is what it is. You got to know how to play it safe. Okay? All right. One of the things that doesn't come up on this review that you need to be able to think about is when you do find an angle from the law of sines, that there's two of them that you have to find if it's a side-side angle. So if it is the ambiguous case, make sure you can find the angle. You subtract from 180 to find the other option, and then test them both because you could have 0, 1, or 2 answers. Don't forget about that. All right, let's look at number 12. So the log ride at amusement park has one giant hill. The ride inclines with an angle of elevation of 33 degrees over a horizontal distance of 50 feet. The angle of depression of the decline is 54 degrees over a horizontal distance of 42 feet. Okay, so the ride is going to go up and it's going to come down, right? And then it's going to look something like this. So we have an angle of elevation of 33 degrees over a over a horizontal distance of 50 feet. And then the angle of depression here, which is the same as this one, is 54 degrees over a horizontal distance of 42 feet. Okay. And I want to find the height of the ride. So this whole side right here is 92. Okay. So there was an issue on the other question because I kind of left out an important piece of stuff. This is a bad question. I mean, depending on how you worked it, you could get 3 different answers. So I want to make sure you understand why it's a bad question and what you truly need to get out of this question. So I'll talk about some options and like why it's a bad question. We are looking for the height. The height is right here. Okay, so hopefully you can see that as 2 separate right triangles. So if I really split that into 2 separate right triangles, then if I use this angle and this side length to find this side, and this angle and this side length to find this side, I wouldn't get the same number, which means it could not exist like this. But this is an instance of somebody, this is why I don't make up questions on the fly when I'm teaching, because the numbers don't work out right. And that's pretty much what happened here. And I did not catch it until I had already copied these and everything, because I was thinking about it one way, but you can look at this different ways. Because when I sat down to do it again, I thought, oh, look at this. I'm looking for the height. So what I can do is I just have a little right triangle right here. So I could just say the sine of 54 is equal to the tangent of 54 is equal to the opposite over adjacent. So tangent 54 equals h over 42. And then boom, you're done. It's a simple right triangle question. So I did that. But if I do that, like I said, if I do that with this number and I do that with this number, I don't get the same thing. That's not the intention of this question. The intention of this question is not to have it just be a direct, boom, simple little right triangle question. The intention of this question is very similar to the ones that you had on your homework. So basically ignoring this part here and using this as a whole. So you have in the big triangle an angle side angle situation. So I have an angle side angle situation, and I can find this side length right here, which I'm going to call x. right? And I can do that with the law of sines. So I have this 92 length right here that's across from this angle, and if I add these two together and subtract from 180, I get 93. So I have a 93-degree angle across from a 92 foot, or what are we, meters? Foot side, so 92 foot side. And then I have this 33 across from x. So I can do law of sines here. So I can say the sine of 93 over 92 equals the sine of 33 over x. So I can cross multiply, do my thing. I get that x equals 50 something. So this is 50 something. And I store that in my calculator, right? Then I can use the right triangle here. Again, I'm ignoring this number because even though the total could be 92, it wouldn't split up into these. So I'm ignoring that number. I'm using the number I just found because you wouldn't have it basically, and you didn't have it on some of the other situations. I'm using the number I just found and this angle to find my height. So that's opposite and hypotenuse, so that's the sine. So I can have the sine of 54 equals the opposite, which is h, over the hypotenuse, which is x, and that's stored in my calculator. So then my height is just x times the sine of 54, and that gives me that h is 40.593. Okay, so, and I want to point out something else, because quite a few of you used those pieces, but you didn't do it like that. You did the law of sines again, doing 90 over, like 90 goes with this and 54 goes with this. So you did the sine of the x in your calculator. I'm sorry, no, you didn't. That doesn't make any sense. Did the sine of, one second, sine of 90 over the x that's in your calculator equals the sine of 54 over h, right? So if we solve that for h, we just solve that for h, like without typing it in the calculator, and look at what you have, and then ask yourself what the sine of 90 is, and see why that works. Even though it's not necessary, the law of sines works, but it's just simple right triangle trig also. So, and then that's it. All right, so then the height of the ride, to answer my question, is 40.593 feet. If you did just simple right triangle trig from the beginning with that 42, you get 57 something, and I don't even know what it is when you get 33, but it's something else. But that's the intention of the question, like the ones on the assignments, where you have to use the law of sines or cosines, and then you find the height, and you go from there. Okay. All right, so let's look at number 13. I saw quite a few people's pictures today drawn incorrectly. So let's talk about how we know what to do here. So 2 towers at a national park spot a forest fire. Tower A spots the fire at a bearing of north 38 degrees west, and Tower B spots the fire at a bearing of north 48 degrees east. If Tower A is 729 meters directly east of Tower B, find the distance from each tower to the fire. Okay, so I'm going to show you what people did wrong first, and one reason why maybe we could kind of catch that something's wrong. So here's what I saw, and I saw this multiple times. So we said, all right, well, Tower A says so remember, this is what's wrong, so if you don't have this, don't be erasing anything. If I go north 38 degrees west, boom, right here, this is 38, and then this would be Tower A. Tower B, north 48 degrees east, boom, like this, and then this is 48, this is B, right? And then I connect these, and these are 729, okay? So this is a no, and here's why. It says Tower A spots a fire at a bearing of. That means the bearing starts at Tower A. I'm standing at Tower A, and I'm looking at a bearing of whatever. This is me sitting at the fire looking at Tower A at that bearing, and me sitting at the fire and looking at Tower B at that. Plus, it goes on to say Tower A is 729 meters directly east. Well, most people that had these triangles, this wasn't even horizontal. If we're directly east, it's a horizontal line. So this is a no, but I want to make sure you understood why. Here's what's actually happening. Okay, I've got my 2 towers. So it says Tower A is 729 meters directly east of Tower B. So make my two towers. Okay, so since A is east of B, this is east, so A is east of B, and this is 729 meters. So then I look at, it says Tower A, so here's Tower A. They spot a fire at a bearing of north 38 degrees west. Boom. This is 38. Tower B spots the fire at a bearing of north 48 degrees east. So this is 48 right here, and this is the fire. So then when I label this, I'm going to subtract 48 from 90, and the reason I know it's 90 for sure is because of this directly east. This has to be horizontal. So that makes this 42, this 52, and this angle 86. So in this case here, and it says, find the distance from each tower to the fire. Okay, so I'm going to call one of these X and one of them Y. So to find this one, 42 goes with X, and 86 goes with 729, so it can be the law of sines. Sine of 86 over 729 is equal to the sine of 42 over X. So do my thing, cross multiply and do whatnot, and I get that X is equal to 488.987. Then I'm going to do Y, so the sine of 86 over 729 is equal to the sine of 52 over Y. Cross multiply, divide, I get that Y is equal to 575.863. Right? And again, this was law of sines by just finding a side. Remember to look at how to find an angle with the law of sines and using the ambiguous case. Then to answer my question, I say that the distance from Tower A to the fire is, okay, so from Tower A to the fire, that was my X, so that's this, 488.987 meters. And from B to the fire is 575.863 meters. Okay, and there you go. Math time tomorrow is open math time. It's not priority, and I will be here before school tomorrow if you have any further questions.